Good morning, students. In our next class, today we discussed about air standard cycle in mainly Otto cycle. Why this is called air standard cycle? Because first we know what is cycle. In our previous semester, whenever we talked about the thermodynamics properties, we said if the thermodynamic properties like pressure, volume, temperature, in a certain point, it may be P1, P1, T1. We go through a path, we reach another point. If it is starting point A and the second point is B, and here the thermodynamic properties is P2, P2, T2, and then we go back another time to a starting point. It is said the initial state and the final state. Here we see that we go from A to B path and then go back to B to A through this A path. Whenever we go back, then the properties, thermodynamics properties are same. That is P1, P1, T1. Now this is construct a reversible cycle. Similarly, it may be like that. It is 1, 2, 3, 4. We go to 1 to 2 this way, then 2 to 3, then 3 to 4, and 4 to 1. Whenever we come back in the initial for a state, from the final state 4, the properties are same. In between, we go through the state 2, state 3, state 4, and come back again in the. This is known as a total cycle. In other way, it can say reversible cycle if the properties are same if we go back. Now, why? Yeah, because for the cycle we consider the change of state for a gas, especially or mainly it is air. For that reason, it is known as air standard cycle. Now, why we are going to read about this air standard cycle? Because following this cycle, our automotive sector are run. That means our automotive sector are dependent or run by following the cycle. This means air standard cycle, where it produces the energy to run this automobile, or you can say it runs to help the engine to produce energy by which our scooter, maybe bike, it is run, or car also. Now, for that reason, we have to learn about this air standard cycle. Now we go to the Otto cycle. This Otto cycle helps to run the CI engine, or SI engine, that means spark ignition engine. Spark ignition engine. What is spark ignition engine? That means, as the term is spark and ignition, that means for ignition of the fuel, whatever used in this engine is made by some spark, and by the spark there is combustion happened, and this combustion is produce the energy by which the engine moves or engine run. And this is happened by Otto cycle. And what kind of this is engine? This is nothing. Whenever petrol is act as fuel mixed with air, then the Otto cycle is applied. Now, how we can discuss the Otto cycle. And before the Otto cycle, we have some assumption that first, all the phases, that means this 4 phase for Otto cycle, it is reversible. And air is act as an active fluid here. Now, for Otto, whenever we go for Otto cycle, we have 2 graphs to represent the cycle. One is known as PV diagram, where y-axis is describe the pressure and x-axis describe the velocity, and another is TS diagram, where y-axis is represent the temperature and x-axis represent the entropy. We know what is the entropy. This is nothing but the dissimilarity in a system or randomness in a system. Now, for PV cycle, Otto cycle, we can draw like that. This 1 to 2, 2 to 3, 3 to 4 and 4 to 1. 1 to 2, 2 to 3, 3 to 4 and 4 to 1. That means all the process 1 to 2, 2 to 3, 3 to 4 and 4 to 1, as I said earlier, all these are nothing but are reversible process, in which 1 to 2 we see that the volume is changed here, and which direction? In the negative direction. That means is volume is reduced. That means a compression is happened. A compression is happened. Second, you see that 2, 3, where we see that the pressure is increased. The pressure is increased. But at that time there is no change in volume. That means V2 and V3 is same. Then it is a constant volume heat addition. If this is heat addition, then the pressure must be increased, because we also assume that there is no friction is happened during the process. That means this is a frictionless process. There is no chance to change in pressure for that reason. Then there is some expansion, that is volume is increased from 3 to 4. That means here 1, 2 and 3, 4 a similar kind of process, which is in general known as reversible adiabatic process or isentropic process. RESV dot reversible adiabatic process, constant volume heat addition, constant volume heat addition, and it is also reversible adiabatic process, and this is also constant volume heat rejection as the pressure is decreased. That means constant volume heat rejection. Now, what are the TS diagram? TS diagram looks like that. 1, 2, 3, we can see that the highest temperature is 3, where the heat addition is 8. That means at that point the temperature is almost the high, and here also we see the temperature at the T3 is the highest. That means whatever we draw here, it is utmost correct. This V is equal to C and V is equal to C. Here, as this is the adiabatic process, we know that for adiabatic process, PV to the power gamma is equal to constant, and it is heat rejection. This 2 is 1. Now, we said previously that is applied in spark ignition engine. For that kind of engine, what will be the form of this PV diagram? This PV diagram, this PV diagram looks like that. It is V, that is P. It is known as looks like that. This is one where is 1, 2, 3, 4, 5, this 6. That means here we see that first intake valve open, the air entered into the engine, then a compression happened for which the volume is decreased, then the heat is added, then what happened? The fuel entered into the system, the air fuel mixture entered into the system, the burning start or combustion process start, that, and then as whenever the combustion process almost happened, whenever the expansion of this by this the produced gas inside the engine have a make a pressure on the piston, and piston go to the bottom dead center, by which the expansion happened, and then the exhaust valve open, all the byproduct is go outside of the engine, and then it comes down to 6, and then ever all the valve is open and the air entered into the system another time. This way the engine run. Now, whenever the engine is run, we must learn about the efficiency of this engine. Then we know it is realistic or not. To find out this efficiency of the engine, we have to know what amount of heat is entered into the system. Then we go for Q1 where it is entered. Then what will be the heat entered? It is nothing but, you see that as it is happened at constant volume process, then our formula look like that, M into CV into T3 minus T2. T3 minus T2. And for Q2, similarly, it looks like M CV T4 minus T1. Then, what will be the efficiency? The efficiency will be one minus heat addition, that is Q1 by Q2. 1 minus M, sorry, it is Q2, it is Q1. MCV T4 minus T1 by MCV T3 minus T2 is equal to 1 minus T4 minus T1 by T3 minus